curious as to why it comes in on my phone before it comes in on my computer. I just heard it come in on my phone. Not yet. Do you know the answer to that? Why is mobile quicker than internet?
No idea.
Let's see, you can see my screen, right?
Yep.
That's not it. Okay. Still not yet. Let me check my phone and make sure that's what came in. No, it didn't. So I still haven't got it. You sent it to David Cowan, 1949 at gmail.com?
I just sent it to your phone.
Well, that's a little problematic. Can you send it to my email address?
Yeah.
Because that's the only, in other words, I don't have access to the stuff that comes into my phone.
Oh, okay.
There's
I'm doing that right now.
Okay. You should have it saved in there, I would think.
Yeah.
So you type the first couple digits, it would give it to you. So how's your day going? How'd your football game go?
Good. JV won 46-28, I think.
Yeah. Is that who you played? You play on JV?
No, I swing. I play varsity and JV.
Huh? Okay.
So it's David Caulfield 19 at gmail.com.
It's David Cowan. What did I do? Did I erase it? David Cowan, C-O-W-A-N, 1949 at gmail.com.
Okay. All right. I just sent the first part of it.
All right. It doesn't usually take that long to get here. I suppose it depends on the internet traffic. Yeah, I just heard it come into my phone. Again, it comes to my phone before. There it is.
And then if you want me to send it again, just let me know.
I think I can read
this. You need a better picture.
You can read it. Okay. Which ones do we need to go over? It looks like you missed a few here.
Let's go over numbers 3 and 4 for right now.
Okay. All right.
And I just sent the second part.
Well, on number 3, first of all, we have to multiply 3 times a plus b. So I have x to the a minus b times x to the 3a plus 3b. That's the second step.
Mm-hmm.
And what's that equal to? When we have the same base, different exponents, we're multiplying, we add the exponents. So add...
That's what I thought. So
add
it'd be...
a minus b to 3a plus 3b.
It'd be 4a minus 2b, or plus 2b.
No? Yeah, actually, you're right. Yeah, no, that's it. Okay. All right. So all of these are going to be the same thing. It's just applying the rules of exponents.
Yeah, that's what I would have gotten that right. I just forgot that because when I got to it, it was either I remembered the adding part. I just didn't know whether that was when you were adding the or adding like instead of multiplying like you are in 3, I thought it was when you're adding that you add the exponents.
Let me give you a trick for memorizing that. When you are multiplying, you add, which is one level less mathematically. Multiplication is one level, or adding is one level less than multiplication. When you are dividing, you subtract, which is one level less than division. Finally, when you are exponentiating, you multiply, because multiplication is one level less than exponentiation. Okay?
Okay.
So those are the 3 primary rules, and between those 3 rules, we should be able to answer anything. So what is this term right here?
That is a negative 3a to the 5th power.
But we are exponentiating. So we have minus
really be multiplication.
3a squared to the 3rd. Let's just solve this first. Remember, this 3 acts on the minus 3 also. It not only acts on the a squared, but it acts on the minus 3. So what's that equal to?
Negative 9a to the 6th power.
Minus 3 cubed is cubed, not squared. In other words, this 3 is not being acted on by the 2. It's being acted on by the 3.
Okay.
You notice why? In other words, if I said this, then the 2 would be acting on the negative 3. But that's not what they've written. They've written minus 3a squared. So the 2 here only operates on the a. But the 3 operates on everything inside the parentheses. So I have to take minus 3 cubed, which is
27.
Negative 27.
No, negative 27?
Because it's minus 3 times minus 3 times minus 3.
Yeah.
3
okay.
3 negatives equals a negative. And then the a squared to the cubed is what?
A to the 6th.
Okay. Now let's handle this. What is minus a to the 4th squared equal to?
It would be negative a to the 16th.
Well, we're going to end up multiplying this 2 times the 4. Because we have...
Oh, no, yeah, it's 8, yeah.
Remember, we have exponentiation going on here.
Yeah.
But the 2 also operates on the negative sign. In other words, if I put a negative 1 in front of that, then this 2 does operate on the negative 1 also, turning it into a positive 1. Okay, so this becomes just a to the 8th.
Okay.
Okay, same thing as if I said, what is minus a squared? What does that equal to?
What was it?
What is this equal to?
Negative 8. It would be negative 2 or 2a.
No, remember that the 2 operates on the negative, turning it positive, and it operates on the a, so this becomes just a squared. So negative a quantity squared becomes a squared. Same way that negative a to the 4th squared becomes a to the 8th.
Okay, I get it.
Okay, so now we're multiplying minus 27a to the 6th times a to the 8th. So what's that equal to?
That would be...
Okay, the minus 27 isn't being changed.
No.
But you have the same base there and the same base there. We have multiplication, so what are we going to do to those exponents?
Add.
There's your answer. Okay?
Yeah, and then also number 5, number 5, 6, and 7 as well, because I made some small mistakes on each of those.
That's fine. But I think at this point you can see that the 3 rules that we have are going to cover anything we come across.
Yeah.
All right. So I don't care how complicated they are. They're not going to be that hard. Well, this is a little different, I guess. But this is different stuff. So multiplying, this is her handwriting?
Yeah.
Okay. Well, when we have 4y minus 9, quantity squared, that's exactly what it is. It's 4y minus 9 times 4y minus 9. You can FOIL those or use every term by every term, what I call ET. Go ahead and do it whatever way you know how to do it. Use either FOIL or ET. What do we get?
You get, it would be, hold on,
Do it term by term, out loud.
4y times 4y would be negative, or not negative, 16y squared.
Okay.
4y times negative 9 would be negative 36y.
Okay.
Negative 9 times 4y would be negative 36y.
Okay.
And then negative 9 times negative 9 is 81.
Okay. So this simplifies to what?
16y squared minus 72y plus 81.
Okay. Let's talk about one other thing here before we go on. It's very useful to be able to do this and this. You're constantly being asked to do this. Rather than FOIL it every time, let's just memorize. What is this equal to?
A squared plus 2a.
And this one here?
A squared minus 2ab minus 2, or plus, yeah, plus.
Okay. So if you have both of these memorized, and we get a problem like 4y minus 9 squared, we can do it instantly. What's the first term?
16y squared.
What's the second term? 2
Negative
times
36y.
2 times a times b. In other words, 2 times 9 times 4y. That's 72y.
Yeah.
The last term is 81. In other words, if you have that memorized, what a minus b squared is, you don't have to FOIL it. You can immediately put the final expression without having to simplify. Yeah. And the only reason I say that this is important is because when you take your ACT tests, when you take your SAT tests, knowing this is very important. They will even ask it to you backwards. For example, I saw this question on a test once. What is 100 squared minus 2 times 100 times 99 plus 99 squared? In other words, the question was, what is that number equal to? Without a calculator. words, this was a test where they did not allow a calculator. This was the GMAT test. If you know this, that's what you're looking at. You're looking at a squared minus 2ab plus b squared. So what is this equal to? A minus b squared. What's a and what's b?
A is 100, and b is 99.
So this whole quantity is equal to 1 squared or 1. Okay? Now, that would have been tough even with a calculator to come up with this. Without a calculator, it would have been really tough. But not so if you know that a minus b squared is equal to a squared minus 2ab plus b squared. So no matter what I give you, if I give you 3x plus 4y, quantity squared, what does that equal to?
It would be 9x squared plus 24xy.
Good.
And then plus 16y.
Squared.
Squared, yeah.
Okay, good. All right, let's go back to your problems here. That was 5. Let's look at 6. So we have 3x plus 5 times 10x minus 8. Okay, surprised you missed this because I know you know how to foil it.
Yeah, it'd be 30x squared is the first term. And then it would be negative 24x. And then it'd be 50x.
Plus 50x.
Yeah, plus 50x.
Necessary to put the plus sign in front.
And then minus 40.
Okay, and that reduces to?
Plus 26x minus 40.
Okay. So you just made an arithmetic error on that one?
Yeah.
Okay. All right, let's look at 7. Hold on. Now, when you take these tests, do they allow calculator use?
Yes.
Really?
Yeah.
Because you can do these on the calculator, on your Inspire CX.
Can you?
You can. You can do everything you need to be able to do on that calculator. It's pretty disgusting to me because it means you could actually answer every one of these without knowing any math at all. But we want you to know how to do it manually. So let's continue doing it this way. I am kind of, yeah, when I've been investigating that Inspire, and boy, every time I look at it I say, wow, this can do everything you have to be able to do. How can they allow you to use these on tests? All right, so let's do this using ET, which is every term by every term. So start me out here.
It'd be x cubed is the first term, minus 3x squared y, plus 9y squared x.
I'm going to keep the x in front of the y just because it'll make it easier to combine like terms.
And then next you have 3y x squared
plus
3y
3x squared y. Again, I'm going to keep the x in front because it matches that term. And if I put the x after the y, I might miss that.
Yeah.
Okay?
And next is negative 9xy squared. And then plus 27y cubed.
Okay. And what you'll find in these is that the first term and the last term never have any other terms in common. So you don't have to search for x cubes. You know it's just going to be that one. How many of these do we have?
Negative 3 and 3, so they drop out.
So those cancel. How many of these do we
And
have?
then those drop out as well.
So they cancel. And you end up with
And then
plus 27y cubed. And in fact, you will notice that this is the sum of cubes factored. Right? If we happened to notice that, we could have gotten it a lot quicker. In other words, we know that a plus b cubed is equal to a plus b times a squared minus opposite ab plus b squared. So if we know that and we're looking at this, we can see that we're looking at a there and b there.
Yeah.
So I could save myself some trouble and know that that's got to be a plus b cubed, which is x plus 3, whoops, hold on. I lost my train of thought as to what I was thinking of there. Let's see, I know that's a plus b cubed, but that's not the answer we got. We got x cubed plus 9y squared. So what we got was a cubed plus b cubed. All right. Let's not worry about that. We did it right. We get the shortcuts. I'm not sure what I was seeing there, but all right. What next do we want to look at?
Numbers 9, 11, and 12.
Is that on another page?
Yeah, it's on the second one I sent you.
Okay. All right. Here we got the sum of cubes. All right, now I know what I was doing. It's not a plus b cubed, it's a cubed plus b cubed that you can factor. In the same way that you can factor, in other words, in the same way that a squared minus b squared factors into a minus b times a plus b, a cubed plus b cubed factors into a plus b times a squared minus ab plus b squared. On that last problem, that's what we were looking at, is this end of it, so we could have immediately figured that the answer was a cubed plus b cubed. And that is what the answer was. So there was a shortcut there. I had a I don't know what, a senior moment or something. So let's see. What is 8x cubed plus 27 going to be equal to?
8x cubed plus 27 would be equal to 2x cubed, or 2x plus 3. Yeah.
In other words, the cube root of that plus the cube root of that times this squared?
So it would be 8.
No,
Not,
squared
squared
2x.
4x squared.
There you go. Minus a times b, which is what?
6x.
Okay. Plus 9. So the only reason you missed that was you got the first term wrong. In other words, a is 2x. So a squared is 4x squared.
Stupid mistakes.
Well, you know, it's frequently. That's what it comes down to. And it's fortunate and unfortunate. It's good in the fact that you know how to do it. That's a big part of the solution. And it's just you need to be more attentive to detail. What I would call being more of a perfectionist. In other words, it's completely different than if I had a student that had no idea how to do these. You know how to do them.
Yeah.
Okay. And this one might be a little different. This one's a little strange. Well, it looks like you know to group them. In other words, our goal is to group them in a manner so that we end up with a minus 2 in both parts. So if I pull out a b here, I have a minus 2. And if I pull out a 3 there, what do I have? A minus 2.
Yep.
So now factor that.
You get a minus 2 in parentheses, and then you get what's left over, which is b minus 3.
Boy, how'd you miss this one? Oh, you didn't?
I don't think I did.
Oh, you got this one right. Okay. All right. Good. No, we didn't need to go.
Yeah, it's 11 and 12 that time. Oh, I think, 11, I did it right. I just used the wrong signs.
Yes. In other words, once we saw this plus sign, we know the signs are the same, and they are this.
Yeah.
In other words, as soon as you know they're the same, look to the sign of the middle term. It's got to be negative, negative.
Yeah. And then 12 was difference of squares, and I just did that wrong.
It is difference of squares. What's the square root of 81m to the 4th?
The square root is 9m squared.
So it's 9m squared minus 1 times 9m squared plus 1. That's the first step. But notice that's not fully factored because I can factor that. So what's that factor? What's a now?
9m squared.
Now take the square root of that whole thing.
3m.
3m minus 1 times 3m plus 1.
Plus 1.
Times 9m squared plus 1, which doesn't factor down. In other words, this is the sum of squares.
Yeah, and there's no such thing.
Well, there is, but that doesn't factor.
Oh, okay.
If it was difference of squares again, we could factor it again. Or if it was sum of cubes, you can factor sum of cubes. In other words, you can factor the sum of odd exponents. You can factor the sum of fifths, the sum of sevenths, all of those. But the sum of even numbers can't be factored. In other words, a squared plus b squared can't be factored further.
Okay.
Miss 13. We need to do 13.
Oh, yeah, 13 I just... Because, like, by then, I was, like, I only had a couple minutes left in class, and I just didn't have enough time to sit down.
What is
and think
13?
through it, so
Is this 13 here? Let me shrink it a little bit.
Yeah.
Oh, that's interesting. I didn't know that happened. If you find the values of A, B, C, and D that make this true. So this is like the final question, kind of a tough...
Yeah, pretty much.
Okay, so the first thing we want to do is eliminate parentheses.
Okay.
The first set of parentheses never hurts. They're not necessary, but it never hurts. The second
Okay.
set of parentheses, we have a lot to do to eliminate that. So I'm going to eliminate the first set of parentheses because it doesn't help either. And now, what do I have after that?
Minus cx cubed minus 4x squared plus 12x minus 5.
And all of that's equal to x cubed plus 6x plus d. So now, let's simplify what we can do here. On the left side of the equation, how many x cubes do we have?
2.
We have that one and that one. Factor out the x cubed and leave the coefficient behind.
3, yeah, 3 minus c. Okay.
Okay?
Yep.
Let's do the same thing with x squareds.
Yeah, there's 2. So it'd be negative a minus 4.
Notice that that has to be a plus 4.
Plus 4?
Well, if you distribute this a plus 4, what do you get? You get minus a minus 4.
Oh, yeah, okay.
So when you're factoring the x squared out, make sure that what's left behind, it works. And the only way to make sure that it works is to redistribute it and make sure you get back to what you started with. Okay?
Okay.
And whenever you have a negative and a negative, this is going to always have to turn into a positive. Okay? And
Okay.
then what about x's?
There's 2.
Okay, so what is it?
12 plus 3b.
Okay, 12 plus 3b times x. And how many numbers do we have? Minus 7.
Yep.
And all of that is equal to x cubed plus 6x plus d. So what is c equal to? In other words, you want to equate coefficients. Whatever coefficient you have on the left has to equal the coefficients on the right. Okay, the coefficient on the right of x cubed is 1. Therefore, 3 minus c has to equal 1.
Okay.
And c is going to equal 2. See where if I plug in c for 2, I have 1x cubed. So that's all we're doing at this point is equating coefficients to solve for these variables. What's the coefficient on x squared on the right side of the equation?
X squared?
Yeah. What's the coefficient on x squared?
1.
0. In other words, it's not there. I could write this x cubed plus 0x squared plus 6x plus d.
Okay.
Okay? So we have to make a plus 4 equals 0. Well, that
So
makes
a would be negative 4.
negative 4. And now the x coefficient. How am I going to solve for that?
It'd be 6.
So 12 plus 3b has to equal 6. B looks to me like it's equal to minus 2.
Yep.
Okay? So we've solved for A, B, and C, and what is D?
D equals... Is it?
It's the constant. In other words, in
Oh.
this equation, D is the constant. So minus 7. Okay?
Okay.
So that's the easiest way to do that problem. I suppose there might be a number of ways you could do it. You could move everything on the right over to the left and then have everything equal to 0 and try to solve it that way. But this really is kind of a classic partial fractions problem. With partial fractions, you set the coefficients equal to one another. If you have a big complicated polynomial on the left equal to a similar polynomial on the right, just equate their coefficients and you solve it.
Okay.
Okay, so that's the end of your test stuff. You have any other stuff you want to go over?
Yeah, I do. Let me pull it out real quick. I'll send you a picture of it.
Okay. I'm impressed with the degree of difficulty of your honors algebra 2 class.
Yeah, it's definitely a challenge.
It is. I've done a lot of algebra 2 tutoring, and it's rare that I see problems this tough. So it's unique to honors algebra 2. You wouldn't get this degree of difficulty in regular algebra 2 for sure.
So this, what I'm sending you is right out of my textbook. It was my homework for this weekend.
Okay?
It is still factoring, but it's like new and different types of factoring that we didn't do before. So.
Tell me when you've sent it. I'll know. I need to check my inbox here periodically. What kind of camera do you have to take these pictures? Is it 5 megapixels or 8 or 12?
8.
It's 8? Okay, that
Yeah.
explains the good quality of them. I use a 5 megapixel camera on my smartphone, and boy, if I don't keep my hands really steady, I don't get anything I can read. So I got to have good light and steady hands. But with the better cameras, not so much. They got a new Samsung now that's got 41 megapixels. Did you send it?
Yeah.
There it is. Where do we want to start?
Right now, I have done up to problem. I'm on 19 right now.
This 19 here?
Yep.
Okay.
She has us do odds.
Okay, so 19 we want to look at. We're just identify all double roots. So what do we have here? Let's distribute this. What's the next line going to be?
For 19, it would be
X squared plus 6x plus 17. So you'd have to move, before anything, you have to move the x squared over to the left side of the equation to get it to equal to 0.
You know what? I prefer to leave the coefficient on my x squared term always positive. Makes it much easier to factor.
So move everything else to the right?
Yeah, let's move everything else to the right, and then I'll just rewrite it.
Okay.
That way I don't have to worry about dividing by 9 minus 1 to solve it. Now this is something else your calculator will do. You can put in a function and it'll factor it for you.
I need to know how to do that.
Well, let's do it manually. At some point
No, I know.
You
I
can
know. I need to learn how to do this.
You can go on just go on YouTube and say, how do you factor on the TX or the TI Inspire CX, and it'll show you.
Okay.
And I'm happy to tell you that kind of stuff also, but you do need to know how to do it manually. I'm convinced.
Oh yeah, definitely.
Convinced you are. So what's our first step here? After we write x and x.
You'd have to do x minus 8.
Hold on, let's take it one step at a time. The next step is to examine the sign on the constant. It's negative, meaning these have to be opposite.
Okay.
Now we're looking for factors of 72 that subtract to 6. What are those?
There's 8 and 7. There's 12
there's 8 and 9.
Or 8 and 9, sorry.
That doesn't subtract to 6.
Yeah. There's 12 and 6.
That works. So now we put the bigger of those factors with the sign of the middle term. So the 12 goes here, the 6 goes there.
Yep.
If I check it, we got plus 6x minus 12x gives us minus 6x in the middle. So, whoops, that's all they wanted there, right? Identify, well, we didn't really identify all the double roots. Let's go back for a moment. What was it? X.
And also they do want us to solve for the variable as well.
Okay. Right, that's identifying both roots.
Okay.
So if we get to this point, what is our solution?
Well, the way she told us because I went to her class during study hall to get more help on this, and you're just seeing in those parentheses what can equal 0. So like with x plus 6, x would just be negative 6.
Exactly. In other words, when you have one thing multiplied by another thing equals 0, then you know that either x plus 6 has to equal 0 or x minus 12 has to equal 0. And if we solve each of those equations, we get x equal minus 6 or x equal 12. So those are your two solutions.
Okay.
Okay. Let's do 21. Y minus 4. Square this for me based on the way I taught you today. Not on foiling. In other words, don't foil it. Do it using a minus b quantity squared. What does that equal to?
It would be... Yeah, y squared plus 16.
Hold on, no. Remember, there's a middle term. A minus b squared. If you were to FOIL it, you'd end up with a squared minus 2ab, there's the middle term, plus b squared. So we need a middle term. Notice that this is not the same as y squared minus 4 squared. This is y minus 4 quantity squared.
Would it be...
So using that, what's the next term?
Would be negative 8. Oh, wait, hold on.
Yep.
No, yeah, negative 8y.
And then what's the next term?
-4.
Squared.
Oh, 16.
So it's plus 16. And it's always a plus. Whether this is y minus 4 squared or y plus 4 squared, this last term is always plus.
Okay.
And that's equal to 2y. So now let's combine everything and put 0 on the right. What do we got? What's minus 8y minus 2y?
Wait, what?
We're moving this over to this side of the equation.
Oh, it'd be negative 6y. Or 10y.
Okay. Plus 16 equals 0.
Sorry, I thought that 2y had a squared on it.
What's that?
I thought that the 2y had a squared on it.
No, it doesn't.
I looked at it.
Oh, I see. Okay. So now let's factor this.
It would be y and then
Go through the steps for me, each step.
well, we have to find two factors of 16 that
First
come
of
out to
all, that's
-10.
the second step is determining what signs we need here. That's a key part of factoring. Do we need plus minus, minus plus, plus plus, or minus minus?
We need minus plus.
Minus minus. If you had minus plus and multiplied those two numbers, you'd get a negative. So in order to get a positive constant, the two signs have to be the same. They either have to be minus minus or plus plus.
And it wouldn't work if it was plus plus because it can't come out to -10.
Exactly. So once you determine they have to both be the same, just look at the sign of the middle term and that tells you what they are. So it's minus minus. Now the third step is factors of 16 that add, because of that plus, to the number 10. Don't worry about negative 10. We just want factors of 16 that add to 10. So what are those?
8 and 2.
So my answer,
Y equals 8 and y equals 2.
okay. 23. We have 3t times t plus 1. Boy, they just can't get away from using t as a variable, can they?
I know, it's really annoying.
It's very annoying. It's almost as bad as when they used g and q in the same equation. Okay,
Yeah.
so distribute these for me.
4t squared, or no, 3t squared plus 3t equals 4t plus 4.
Now combine.
You get negative 3t squared minus t plus 4.
Minus 4.
Minus 4, sorry.
The way I think about algebra is forget this stuff of minus 4t on both sides and minus 4 on both sides. What I do is if I want to move this to the other side, I just do it and change its sign. If I want to move that to the other side, I do it and change its sign. Okay, so now let's factor this. Now the factoring gets a little harder because we have a different coefficient. What's this and what's this?
It would be 3t, and then t in the other one, and then...
Now we can still use the second step of our factoring process, which is to examine the sign. So what does that tell us?
that it has to be a minus plus.
Well, it has to be a minus plus, but in this case, that can be different than a plus minus. So we have to allow for both. In other words, if it was just t and just t, and I know the signs have to be opposite, minus plus is the same as plus minus. But in this case, because we have a 3 here and a 1 here, these can be, in other words, this could be a different solution. So now, and we can no longer make statements like factors of 4 that subtract to 1. Those go out the window once you got a coefficient in front of these. So it comes down now to just kind of trial and error. So factors of 4 for sure. Well, that's 2 and 2 or 4 and 1. So basically, let's just start trying them. And I always recommend to people to try the closest ones first. So I'm going to try a 2 and a 2. Does that work?
Yes.
Well, I get minus 2t and plus 6t. That does not give me a correct middle term. So that didn't work. Let's try the 2 down here and the 2 over there. Does that work?
6. No.
Okay, so 2's don't work, so it must be 4 and 1. Let's try 4 and 1. Does that work?
No.
Yes, it does.
Oh, it does?
Uh-huh. There's your minus 4t. There's your plus 3t. Add them together, you get minus t. That's our middle term.
I looked for the wrong thing.
That's the way to factor as far as I'm concerned. That's the best method, is exactly what we just did there.
All right.
Okay, I mean, I know there's lots of methods. There's the California method, there's the box, there's the diamonds, there's all kinds of them. But to me, this is the easiest way to factor. So,
yeah, I was taught the diamond one.
Okay, well, I have no problem with you using whatever you were taught.
This is easier now that I'm starting to get it more.
Okay, cool. So what's the answers here? T is equal to what?
T is equal to... well, T would equal -1, and then
Solve this.
it'd be 3/4
4/3.
or 4/3.
And move the 4 to the other side and divide both sides by 3. Okay? That was 23. Let's do 25. 25 is a little different. Might look like you would want to multiply all of this out. But notice that the solution to all of these, when you have it set equal to 0, is to factor it, not to multiply it out. So the last thing in the world we want to do here is multiply x minus 1 times this. What we want to do is we want to factor that.
All right.
Okay, so what does that factor into?
X and X, and then
What are the signs?
a negative and a plus, or a plus and a negative.
And either one is the same because these coefficients are both 1.
Yeah.
So I don't need to write it like I did before. Now I want what? Factors of 2 that do what?
Come out to 1, positive 1.
That subtract. In other words, I want factors of 2 that subtract to the coefficient, which is 1. Just that number. So that would be 2 and 1. Subtract to 1. Where's the 2 go? Where's the 1 go?
The 2 goes in the positive section, the 1 goes in the negative.
Okay, so now this is what we were looking at. And now what is my solution?
X equals +1, +1, and -2.
Okay. Identify all double roots. Okay, so there's your double root, huh? That's what they mean by double root. That's called multiplicity of 2. In other words, there really are 3 solutions to this equation. It's x equals -2 is 1, and x equals 1 is another with a multiplicity of 2.
Yeah.
Okay.
And then my teacher said that the exponent gives away how many answers you're going to end up with.
Yeah, third-degree polynomials, you have 3 answers. Quadratics, you have 2 answers. Fourth-degree polynomials, you have 4 answers. They're not always different answers, but there's 4 answers. Okay. So how many answers are we going to have here? Before we do any.
It looks like 5.
Okay, good. What can we factor?
We can do the y squared minus 9.
How's that factor? Difference of perfect squares? Take the square root of that minus the square root of that times the square root of that plus the square root of that.
Y minus 3 and then y plus 3.
Okay. It's always the way to handle difference of squares. So now, what are our solutions?
You have...
What are our
Negative.
five solutions?
Well, you have y equals 0 for 1. You have y equals 3. Y equals 3. Y equals -3.
It's only 4.
And the lab.
Let me rewrite this first term. Instead of y squared, let me make it y times y.
Oh, so y equals 0 and y equals 0, y equals 3 and 3 and then -3. Oh, okay, I get it now.
Okay? All right. Got done with that problem right at the right time. Good timing.
And also, my mom wanted me to ask you, are you free on Monday at 7:15 or 7:30?
Let me pull up my calendar here and look. My Monday is a tough evening. I got lots of permanents on Monday in the evenings. What is that? That's this Monday? That's what my Monday looks like.
Oop, my screen's not on.
Can you see that? In other words,
Yeah.
I'm full from 3:30 on. I have a spot from 2 to 3:30 open. And let's see, you're scheduled for Saturdays at noon. And weren't we going to do you twice a week? When did we make? We didn't make another permanent time. Okay. So we're looking for the other half-hour slot.
Yeah. What about, does Tuesday at 7:30 work? Can I read that?
Definitely does.
Okay. Can we do that, please?
Sure. And you want to lock that up permanently? Does that work?
Yeah, I think so.
You can always change it if it doesn't. If you have a change in your schedule or something.
Okay, but yeah, that's good for right now.
And you only want a half-hour one on that?
Yeah.
Let me lock it up right here. All right, you got that half-hour slot until you tell me you don't want it anymore. And
Okay.
same
And
thing with
I also have a quiz
the
on Wednesday, so that Tuesday is going to
Okay.
help.
Is this Saturday at noon? Is that good permanent time, or do you want to make that 12:30? Was there just something special today?
No, can we make that one 12:30 as well? But this is the last week, and it'll be 12:30.
Sure. This is going to change them all, so let me know when it goes back to 12.
All right, sounds good.
So this weekend it'll be 12:30, but after that it goes back to 12?
Yeah.
Let me move that. All right. All of that's done. Whoops.
Okay.
Maybe not. We'll get it right. Okay, so the next thing is I'm going to see you or 7:30 on the 5th Tuesday. Is that right? We're already to the end of the month? Yeah.
I guess so.
This is I'm a week ahead. I'm a week off here. Hold on a second.
Yeah.
Okay.
29th,
No, the next time I'm going to see you is the 29th at 7:30, and then on the 2nd at 12:30. Okay. Sounds good.
Okay.
Have you, did you get a chance to look at that recording at all?
No, I have not. I've been pretty busy these past couple days, but
Did you get my email with the link?
I believe so, but let me check real quick.
Because I can give it to you real quick here just by pasting it into the chat window, if that's helpful to you.
When did you send it?
The day after our last session?
No, it's not on here.
Okay, hold on. Let me see if I can pull up your page. It's Jackson. Let's see, must be 4. Yeah, here we go. So here's your page on my website. There's the link. I'm going to copy it and paste it into the go to meeting window right now. You see it in the chat window?
Yeah.
Click on that link.
Okay, hold on. Click on the link.
Uh-huh.
All right, I just did.
And now save that page
Oh, okay.
in your favorites.
Save it.
Uh-huh.
Okay.
And you can always get back to it. In other words, that's the link right there. And then when you go to this page, if you want to play it, just click on that. It's a YouTube file, and it'll play it that last session. Okay? And what I'll do is I'll paste it in top. In other words, the top one's always going to be the most recent one.
Okay.
But every one you have will be in here. I'll leave them all in.
All right.
Okay? All right, Jackson. Talk to you Tuesday.
All right. See you later. Thank you.
You're welcome. Bye-bye.